Welcome to the 2018 presentation of the Solar Cell Group of the Jewel Fellow Program located at the University of Connecticut. My name is Todd Richmond. I teach physical and environmental science at E.O. Smith High School located in Storrs, Connecticut.
I'm Chrissy Pizzano. I teach physical science and chemistry at Sacred Heart High School in Waterbury, Connecticut.
As a part of the Da Vinci program, we took a tour of the water treatment and reclaim facilities located near the campus of the University of Connecticut. On the tour, we were provided with information regarding how engineering practices are used in a water treatment facility such as this one, which can be found in every town throughout the country. A town's treatment of wastewater is extremely important to ensure the health of all of its inhabitants.
Also during the Da Vinci program, we visited the student-run farm where air and water quality testing is performed. The farm is located near a cornfield which uses pesticides, which makes this a unique area to test for air quality of an organic farm. Other projects included are an aquaponics garden, bees, microbes, worms, organic farming, and a solar project as well.
During our first week at the Jewel Fellow program, we had the pleasure of working with Dr. Christina Wagstrom, learning about her air quality research here at the University of Connecticut. We spent the week learning about what types of human and natural processes can affect air quality on a local and national scale. We used the CircuitPython program and learned how to write code, which our air quality sensors will then use to record continuous data. We spent a day walking around the campus of UConn to collect data points of air quality before presenting our research to the fellow teachers of the Da Vinci program on the final day of the week.
Later in the program, the Jules Fellow group took a trip to Quinnipiac Valley Community College, located in Danielson, Connecticut. On this tour, we were given an inside look at the equipment and curriculum used in their 2-year program, which helps prepare students to continue their education in a 4-year program or go straight into the workforce. Associate's degrees offered at QVCC include Technology Studies, Computer-Aided Design, Engineering Technology, Environmental Science, Lean Manufacturing, and others to help prepare individuals for their future careers related to technology, engineering, and manufacturing.
Another field trip attended by the Jewel Fellow group, which is my personal favorite, was to Hooker Brewery located in Bloomfield, Connecticut. Throughout this tour, teachers were given a detailed description on how local craft beer is made through the lens of chemists and entrepreneurs alike.
The final field trip of the program included a tour of Whitcraft LLC located in Eastford, Connecticut. This manufacturing company has adopted an assembly line style which minimizes the amount of space being used within their building to efficiently mass-produce high-quality parts in the ever-evolving aerospace industry. This company is one of the many local businesses which will employ individuals that possess an education in either the manufacturing or engineering fields.
Throughout the remaining weeks of the Jewel Fellow program, our group learned in detail how solar cells can produce voltage and current to run everyday appliances while producing a minimal carbon footprint. To understand the circuit design, the range of our research included the basics of algebra when using Ohm's law, up to levels of calculus to understand how sine and cosine waves are interpreted when reading voltage and current outputs.
Some of the experiments conducted using the solar cell panels included measuring the differences of voltage and current when using a full panel as opposed to half a panel, differences in voltage and current when the panels are facing direct sunlight compared to when it's turned away, measuring voltage and current during times of mostly sun, and comparing that data to days that were mostly cloudy and measuring how voltage and current change when changing the resistance of the circuit.
The materials needed to successfully run these experiments included a differential probe, which measures the voltage between 2 points, as well as eliminating noise to allow for a more accurate reading, an oscilloscope, which produces the measurements of voltage and current, resistors to maintain an appropriate amount of voltage in the circuit, as well as an ammeter clamp, which assists in measuring the current of the circuit.
Data collected throughout these experiments clearly show how voltage and current can change when manipulating variables in a controlled experiment.
Uses in the science classroom for these experiments could include plotting data and graphing skills, identifying and changing multiple variables in an experiment. Measurements recorded from these changing variables can be used to conduct a lab experiment as well as a written lab report, and extending this learning to advantages and disadvantages of renewable and non-renewable energy resources.
In the final weeks of the Jules Fellows program, our group used Arduino boards in various experiments. To complete many of the fun projects which could be used in the science classroom, a breadboard is required. The role of the breadboard is to allow for the Arduino circuit to be able to produce a function that is being asked when writing a particular computer code for a specific project. Breadboards can allow for students to use their understanding of circuits to insert their configuration of materials such as jumper wires, LED lights, resistors, and other materials depending on the assigned project are set up correctly. If the circuit is not set up correctly or the computer code is inaccurate, the project will not function as it's supposed to.
Software and code for projects are available for free at arduino.cc. There are hundreds of projects available online for students to explore, which control the blinking of LED lights, motion sensor detectors, playing the melodies of songs, collecting and graphing data, just to name a few. Uses of Arduino in the classroom can be utilized through the collection of data and graphing, exposing students to the field of computer coding and its relationship to sensors. And if time and funding is available, you can start a club based around these programs to allow limitless options for students to explore a world which includes many 21st century skills.
The last project we worked on was setting up the code for a stepper motor, which is a DC motor. Each stepper motor has multiple coils that, when energized in sequence, cause the motor to rotate.
Finally, we'd like to thank Arshia Mirza and Dr. Ali Bazi for organizing our Jules Fellow experience, Dr. Christina Wagstrom for the Da Vinci Project, and Randy and Ida for all work that they've done to help develop this program. Lead wires to the resistors. Resistors to differential probe. Power source for the oscilloscope, reading voltage and current. One panel with direct sunlight.
Here's our code running our stoplight on this board. So our green is on, our yellow is on now for 2 seconds, red is on for 3 seconds, and green is on for 5 seconds. And here's our board. Here's our breadboard. You can do the setup.
This is one pole, this is the other pole, this is yet another. And this is another.